Today, we're going to pull back the curtain on modern web security. We're going inside an AI-powered system to see how it builds a smarter, faster shield to protect us all online.
So let's start with the big, central challenge. How in the world do you spot a hacker and stop them in less than 20 milliseconds? To put that in perspective, that's literally 10 times faster than you can blink. That's the insane speed these systems have to work at, all without slowing down the internet for the rest of us. And the reason for that need for speed? Well, it's because every single website is under a constant digital siege. We're talking a relentless barrage of automated bots and, of course, clever human attackers, all hammering away looking for a single crack in the armor.
You know, what's so tricky is that a perfectly safe request and a malicious one can look almost identical. On the left, you've got a normal user just searching for a product. Simple enough. But on the right, a hacker has hidden a nasty little bit of code right inside the search box. That's a classic attack called cross-site scripting, or XSS. To an older system, it just looks like a weird search, but it's actually a weapon.
And this is exactly where traditional security just falls flat. Most older systems rely on a fixed set of rules, basically a list of known bad things. But attackers are always evolving, constantly cooking up new ways to get in that aren't on any list. It's like trying to catch a master of disguise with a bunch of outdated wanted posters. It just doesn't work for long.
So if static rules are out, what's the answer? Well, we have to build a smarter shield. We need something that doesn't just look for old attacks, but can actually spot the signature of a brand new threat as it's happening. And this, right here, is where AI enters the picture.
Which brings us back to that critical number, under 20 milliseconds. The entire check has to happen in that tiny window of time. This isn't just a goal, it's a non-negotiable requirement of the system. It has to be incredibly intelligent and unbelievably fast. You can't have one without the other.
This quote really just nails the whole challenge. The goal is to create this digital security checkpoint. And that checkpoint has to be smart, sure, but also lightning fast. It needs to make its decision, what the engineers call inference, in that sub-20 millisecond window, so it can provide security without creating a massive traffic jam on the internet.
All right, so to really get how this works, let's follow a single incoming request on its journey. We're going to trace its path from the moment it hits the network through a whole series of high-tech inspections and all the way to the final verdict. So here is our digital security checkpoint in action. At step 1, the perimeter, that's like basic crowd control. Step 2, the gateway is your first ID check. It instantly blocks anyone on the most wanted list. Next, in step 3, the profiler pulls the request aside and gathers intelligence on it. That intel is then passed to step 4, the AI brain, which makes the critical judgment call. And all of that leads to step 5, the verdict. Allow, block, or maybe issue a challenge just to be sure.
So what is this AI brain actually looking for? It's not magic. It's just really advanced pattern recognition. It's looking at the metadata. Where's this request coming from? What's it asking for? It checks behavioral signals. Is this person acting weird? Is their activity normal for the site? It scans the payload. Does the actual content of the request look malicious? And finally, it checks the reputation. Is this IP address a known troublemaker? It weighs all of these things together to come up with one single risk score.
Now, here's a really important detail. The AI score doesn't act alone. It's not the ultimate decider. That score gets merged with other signals, and critically, with hard-coded rules set by human security experts. This creates this incredible hybrid system that gives you the best of both worlds, the adaptability of AI and the rock-solid control of human experience.
But the real superpower of this whole thing, the thing that makes it a true game changer, isn't just how smart it is right now. It's the fact that it's designed to constantly get smarter. It's a system that learns, and it learns using a feedback loop. It's a simple idea, really. You take the results of what the system did, its successes and its failures, and you feed that information right back in as a new lesson. Every decision helps it make a better decision next time. So here's how that cycle works in practice. The system flags something suspicious. A human analyst, an expert, takes a look and makes the final call. Was it actually a threat or just a false alarm?
That answer, good or bad, gets added to the training data. The AI model then gets retrained with this new verified information, and the smarter, updated version is rolled out. This human-in-the-loop partnership is absolutely vital for making the AI more and more accurate over time. Okay, so this all sounds fantastic, but how do you actually build it? I mean, this isn't just some high-level concept. The material we're looking at lays out a real-world, practical blueprint for taking this system from an idea on a whiteboard to a shield that's actively protecting a website. And you might be shocked at how fast a team can get a basic version up and running. A proof of concept can be done in just 4 weeks. Week 1 is all about getting the skeleton in place, the basic plumbing. Week 2, you train that first version of the AI model. During week 3, you build the engine that makes the final call and the dashboard for your human analysts. And then in week 4, you plug it all together and start testing with live traffic. It's an intense but totally achievable way to build something this powerful. So the real key takeaway here is that this isn't science fiction. It's not a research paper about something that might exist one day. This is an actionable engineering blueprint that shows exactly how these systems are being built and deployed in the real world right now. Which, of course, leaves us with one final, very big question. In this endless cat and mouse game between attackers and defenders, what happens when the attackers start using powerful AI too? Can a defensive shield like this one always truly stay one step ahead? It's something to think about.